Okay, so we have rational functions here. If I'm given this function x minus 3 over x squared minus 4x minus 21, I can certainly tell it's a rational function because it's a polynomial divided by a polynomial. When you're asked to find the domain, so that's what they're asking me to find. That basically means what are x values that you can plug in that's not going to make the denominator blow up, right? Which means we cannot divide by 0. So what you want to do is you want to factor the denominator. And so I go back to my factor in a binomial. I look here. I know x times x would give me x squared. I look at 21 and I just automatically think of 7 and 3. 7 times 3 is 21. And I need to subtract, and that works, right? 7 minus 3 will give me 4. Because it's a negative 4, the negative needs to go on the larger value. And of course, you could easily FOIL this out and see that this works. So nothing changes up here on the top. So what this is saying is I can let x be any value all the way from negative infinity until, so I've set both of these equal to 0, x plus 3 equals 0. That would be x equals 7 and x equals negative 3. Until I hit negative 3, and I can't touch it, so it needs to be a parentheses, union, then it jumps from, oops, I forgot my negative sign there. It jumps from negative 3 to 7. And yes, I know my number line is not drawn to scale. And then it jumps from the other side of 7 and heads out to infinity. So the domain would be any real number except those that were x equals negative 3 and 7.